So this is the last set of notes for the chapter. Assessing normality means you're going to be given some either data values and you have to justify whether it would have a normal shape as a distribution or not. We need to check that a distribution is roughly normal before we can use normal CDF or inverse norm in the calculator. Here are the test scores for 32 students in a stats class, and the great news is they're already listed least to greatest. I want you to know how to take this data and make either like a histogram or a box plot in your calculator, because that would be a really quick way to see if this distribution was roughly normal. So it says enter the data into list 1. Let's do that first, and then I want you to pause. Try not to get ahead of me here. Stat, edit, clear out anything that's there. Stat, edit, and carefully be sure that you've entered 32 test scores. And if you just mess up on even one of these test scores, it messes all of your statistics up. When you're finished, you should be on the 33rd row. Since there are 32 listed, you should end up on the 33rd row. That's how you know you've entered all 32. If you get anything different than I do when we look at the histogram, it's because you entered one of the data values incorrectly. Raise your hand if you're still entering the scores. Okay, no problem. Some of you are double checking to make sure they're all correct. That's fantastic. Again, I'm teaching you on the TI-84. If you have a different calculator and I lose you on where things are located, we can figure it out together. So now what I'm going to show you is how your calculator can graph this as a histogram or a box plot, a distribution that you can see. Does it have that kind of bell-shaped curve? It says change the stat plot settings. So right up here in blue, you see stat plot. So since it's in blue, you need to hit second, and then y equals. That very first option, plot 1, we're going to turn it on, so hit enter. If it's off, it will look like this. You need to arrow over to on and hit enter. We're going to turn on stat plot 1, which means we want our calculator to graph everything in list 1. Does anybody need me to repeat any of that? Then your calculator lets you pick all different types of graphs that you want. Let's pick a histogram, which is going to be the very top right option. That's the histogram, all the bars touching. Hit enter, and it'll highlight that. And we want it to be taking the values from list 1. Does anybody have something other than list 1 sitting right here? Okay. Go ahead and hit enter and enter. And it's not really going to change off of this screen. Hit graph. You're going to see all different kinds of things depending on, I'm hoping that you don't really see what I see right here, but your calculator has graphed the histogram. You just may not be able to see it. Hope you're listening. You're going to use zoom, and then all the way down at option 9 is zoom statistics, zoom stat. When you make it zoom to your statistics, it's going to show you the histogram. Pretty cool, right? Let's say we want it to graph this as a box plot. So go back to your stat plot. That's second y equals. Go back into the first one. It's already turned on, and then we want it to graph. I actually don't know the difference between these box and whisker options. Let's just all pick the one that is the very first one, the bottom left. And it's going to ask you, do you want the outlier to be a little circle, a plus sign, a dot? That's really not going to matter. But if you go back to graph, I think ZoomStat won't change anything. No, it won't change anything. I might scoot it over a tad. But here's the box and whisker plot. You can see that there aren't any outliers. It's roughly symmetric. So do you think, either based on the histogram that we had up there a second ago or this box plot, that this distribution is, the question is, do you think it's approximately normal? Do you think it has that symmetric, bell shape, unimodal? Yeah. And I think looking at the histogram is actually really the easiest way to tell. Box plots have kind of a weakness in showing that. So is this distribution approximately normal? Yes. You can use your calculator to graph distributions to have a visual for assessing normality. That was the whole point of doing that with you, was to let you know you're allowed to enter in the values into your calculator and assess for normality. Now, if this was a free response question, you wouldn't be able to just put yes because I put it in the calculator. You would need to maybe sketch the graph itself, or do what part B is going to lead you into. It tells you the mean of these test scores, and it tells you the standard deviation of these test scores. And if you're assessing normality, then you can check for the empirical rule. Does anybody remember what percentages are in the empirical rule? What's the first percentage? Yes. 68. What's the next percentage? 95. And the last one? 99.7. Yeah, some people even call it the 68, 95, 99.7 rule. I think it's easier just to say empirical. But that's all we're going to check for really quickly, is we're going to see what percent of the values are within 1 standard deviation of the mean, within 2, and within 3. And if we get percentages close to what the empirical rule says, then we have assessed for normality, and we can say, yes, this is roughly normal, or approximately normal. Yes?
If they didn't give us a standard deviation mean, what is the way then that you can find that from this one?
That is a great question. So if you've entered all of your data into list 1, you can actually have your calculator tell you the mean and standard deviation by going to Stat, Calc, one variable statistics. Make sure, look at mine. Mine's wrong right now. It's pulling everything from list 2. Well, my list 2 is empty. This is because I did something different on my calculator earlier. So I need to just make sure that that's list 1. And it will tell you the mean and the standard deviation of the sample. Great question. Yeah, because it might actually leave you hanging on the AP exam, and it might not give you that information. And then you, if you want to use the empirical rule to assess for normality, you would have to have those. Very good. So let's kind of move through this one quickly, because this can be a tedious process. We're going to say X bar plus or minus 1 standard deviation, and then we'll calculate X bar plus or minus 2 standard deviations, and then we'll do the mean plus or minus 3 standard deviations. So we're going to do 3 things here. If you just go to your normal calculation screen and you type in the mean minus the standard deviation, that's going to give you 81.031. The upper end of that would be the mean plus a standard deviation, which will give you, ooh, I'm sorry, that's wrong. It should give you 74.523. all the way up to, when you add it, it's going to be 87.539. And then I just need to know what proportion or what percentage of test scores are within these values here. So I'm looking for anything from 74.5. So would I include the 74s? No. 74.5 all the way up to 87.5. I'm just going to use brackets there, and I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 21 of the 32 test scores, which is about 65.6%, are within one standard deviation of the mean. You might be thinking, oh, well, that's different than 68%. Let's keep going, because I think that's pretty darn close to 68%, relatively speaking. Let's do the mean minus 2 times the standard deviation of the 2 times the standard deviation. That would put your lower boundary at 68.015. So I'm just moving us right along because I've already done the math. And then if you take the mean and add 2 standard deviations, that takes you all the way up to a test score of 94.047. So now we're looking at slightly above 68, so don't include the 68, all the way to 94 and some change. You can either count all of those, or you can say, well, there were 21, and then I'm just adding 9, so that's 30 out of 32. And 30 out of 32 is 93.75%. Which again, relatively speaking, that's pretty close to 95%. And then the very last part, so this is tedious, take your mean and subtract 3 standard deviations of the mean. That's going to take you all the way down to 61.507. If you add 3 standard deviations, it's going to take you up to a test score of 100.555. And that ends up being all of the test grades, so that's 100%, which of course is very close to 99.7%. So I'm going to say that if I'm assessing for normality, that this would pass the test for the empirical rule. It's approximately normal. That's why we use the word approximately. The next little part, if you are, for any reason, like reading the textbook to kind of follow along, the online text or anything, there's a little section on normal probability plots, and the great news is you don't have, there won't be any of those on the AP exam. You don't have to know how to interpret one or draw one. So if you're following along in the textbook or reading the text, you can skip that part. By the way, we did, I don't know if I've mentioned this yet, but they did give us the grant for giving you access to the online, updated online text. As soon as we get those, I'll let you all have access to that, okay? All right. This is a really weird question, and this is kind of why I decided to go ahead and do today's notes. Because so far, I really haven't shown you anything new. You have a test question like this. It says, another distribution of test scores has a maximum score of 100. Here's the mean and here's the standard deviation of these test scores. Can this distribution be approximately normal? They like to ask this question on the AP exam. So it's yes or no, and then we're going to have to justify it. So I want you to take a note. For questions like this, know that the maximum / minimum, so sometimes it might say the minimum score is blank instead of the maximum score is 100. If it tells you the maximum or minimum, or shows you the maximum or minimum and the mean and standard deviation, then you need to understand that the maximum or minimum should be about 2 to 3 standard deviations above / below the mean. Above for maximum, below the mean would be where the minimum is. In a normal distribution. The question is, we are assessing for normality. We're given some information. We're given the maximum value, the mean, and the standard deviation, and we have to prove whether or not this could be normal, that bell-shaped curve, just based on this information. Well, it says that the maximum value should be about 2 or 3 standard deviations. Since it's the maximum, that's going to be above the mean. Well, there's a formula that is built specifically to tell you how many standard deviations above or below the mean a value is sitting. What is that formula? It's going to be so very important on your test next time that you know this formula. It's kind of the only formula we've looked at this chapter. Yeah, you guys, some of you haven't made the connection yet. A z-score, that's what it is by definition. It tells you how many standard deviations above or below the mean a value is. Value minus mean divided by standard deviation. Well, the value that they gave us was the maximum score of 100. The mean is 92. And the standard deviation is 10. Now, I know that the maximum value should be sitting 2 to 3 standard deviations above the mean. So I know I should get a positive answer, because negative would indicate below the mean. It should be positive, and it should be somewhere in the 2 to 3 range. So let's calculate it. Do you remember how to get your fraction template? Alpha y equals enter. Or some of you can just put 8 on the top, because you're smart like that. If you get a fraction, hit math. Tell your calculator I want it as a decimal. And we got 0.8. That means this. The maximum is only not even 1 whole standard deviation above the mean. There's no way that this distribution of test scores could be approximately normal, because again, our answer should have been somewhere in the 2 point blah 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 to 3 range. If you are like a visual person, for normal distributions, we always go 1, 2, 3 standard deviations to the left and to the right. Your minimum value should be somewhere right in here. That many standard deviations below the mean, and your maximum value should be somewhere right in here. If it's wildly different than that, then you have the math to back it up, and then you could say, no, this is not approximately normal, because the maximum score is only 0.8 standard deviations above the mean, and it should be 2 to 3 standard deviations above the mean. The only thing that would change if this was a minimum problem is you would be looking for a negative z-score. It'd be -2 to -3 that you were needing to get for the minimum. So just know that that's going to be a test question, and I wanted to expose you to that. That's it for today's notes.